I was gonna try, welcome everyone. I don't know who's here today. I was gonna try and do the Google Meet, but I don't think it's working. It doesn't seem to be working. Um, so, okay. Unfortunately, the Google Meet app didn't seem to work. So, I'm not sure. I guess that's not gonna work. I'm gonna give some more instruction though, later today about the Google Meet app. I'll try one more time here before we start. I'll see if anyone's going to be joining us. Usually there's someone that joins us, right? Okay, so let's see if anyone's going to tune in with me. So the app did work. I'm on Google. We'll see if anyone joins us on the app. So I'm going to keep streaming. We are starting a new class, a new course, and I did have a test that was due today. So if you did hand your test in, great. I'll mark it and get it back to you. And we'll just continue on. Now, we are starting the graphing portion of this class, so you're either going to need a graphing calculator very shortly, so this one, or you can also, I had given people sometimes the info on a stick, but I also there is you can download it on your Android phone as long as you don't have an iPhone. There's a phone app that you could use. I could try and guide you through that if you needed to. So let's start. Calculator right now. The other option is for people without a graphing calculator. There's a program called Desmos. So you can use this program called Desmos, and it doesn't operate like a graphing calculator at all. It's a computer program. It's free, and it makes applied math very easy. We do use the graphing calculators in our classes, though, just because we have lots of graphing calculators in our school normally in a normal school year, and we don't have a lot of computers. We don't have computer labs, not enough computer labs to use computers in all of our applied classes. So Desmos is a great option, and I will try and do both approaches in class. It might be kind of difficult every day, but I'm going to start with the graphing calculator, and then if anyone doesn't have access to graphing calculator technology, then we can also use Desmos. So intro to graphing and linear functions. The word linear function, you can see the word line in linear functions. So linear functions also we're going to end up graphing lines. Today we're going to do lesson 1 and I think lesson 2, because we'll see how far we get. Lesson 1 and 2 are quite straightforward. We've got lesson 1, lesson 2, Cartesian plane. So that's a very technical term. The Cartesian plane is something we use to graph. Now, you've all seen a Cartesian plane. I know you have. You've all seen one before. It's just an X and Y axis, and in a mathematical sense, and to try and make sense of it mathematically using a graph. Because a graph is a picture. There's an old saying, a picture's worth 1,000 words. And that's so true. We can quickly see in a visual what's happening on a graph. That sometimes if we just have charts and tables of numbers, the story, I think, could be obscured or a little hidden when we just have charts of numbers and we don't know how to interpret them. But a graph helps us interpret those numbers a lot easier. So all that a Cartesian plane is, it's called the Cartesian coordinate system. In this system, there's a horizontal line that's called the x-axis and a vertical line called the y-axis. They're joined at 90-degree angles, and together they create a Cartesian plane. Sometimes you might see a grid on the Cartesian plane, like you have a little grid here. And it just depends on what kind of data that you're plotting. Sometimes there is no grid. You're just plotting on just a Cartesian plane that looks like this. And quite often in a final exam, that's all they'll give you. And you have to create your own scale using a ruler, right, with little ticks, etc. The grid can be small or larger depending what kind of numbers you're using. If there's no number indicated, it's assumed that each tick is 1, but you really should clearly label a scale so that the reader knows what kind of numbers you're dealing with. So because we have an x and a y-axis, we are plotting data values with 2 numbers associated with it, right? 2 coordinates. So we're usually given this data in point form like this. This is called a coordinate point because the coordinate, there's an x coordinate and a y coordinate. The x comes first, just like in the alphabet, x then y. So points are given by giving 2 coordinates that give the x value first, then the y value. Now, the x-axis, if you think about it, the x-axis is just the number line, right? We've seen this number line before. So it's just that same number line you learned in grade 1 or grade 2 or kindergarten. This is just the number line, right? And then we also know that there are negative numbers. So I have positive numbers, negative numbers. And then I also have the same thing going this way, right? Positive numbers, negative numbers. So this is a horizontal number line. This is the vertical number line. We join them together at a 90-degree corner, and it creates a coordinate system. So when I'm given the coordinate 3, -2, this is my x coordinate. And this is my y coordinate. And you just find where 3 is on the x-axis. So here's where 3 is on the x-axis. You find out where -2 is on the y-axis, and that's where it is. And you just join your fingers, and together they meet at the coordinate point 3, -2, right? So this is where A is. When we write the point, the first coordinate is always the x coordinate, and the second coordinate is always the y coordinate. This is why it's called an ordered pair. The order matters, right? The first number is x, the second number is y. Write these numbers separated with a comma, and they're nested in a pair of brackets, okay? The point where the x and the y-axis meet is called the origin. So this is the origin right here, okay? If I just draw a little arrow there, that's the origin. And it's the point where the x coordinate is 0 and the y coordinate is 0. That's probably pretty explanatory in the picture, right? That's a really important point because that's where the number lines meet at the 90-degree corner. And that's where the number lines, the x and the y, both change from positive to negative values, right? Now, another thing about the Cartesian plane is we refer to it because the axes meet at 90-degree corners. We have this perfect 90-degree corner. What happens is that creates 4 quadrants. That prefix quad means 4. This is referred to as quadrant 1. This is quadrant 2, quadrant 3, quadrant 4. Notice we travel in a counterclockwise direction. Roman numerals are usually used for the quadrants, but it's not, we don't have to be that fussy. You could call this quadrant 1, quadrant 2, if you want to do quadrant 3, quadrant 4 as well. Okay. So now, example 1, plot the following points on the coordinate system below. So this is just getting practice on the Cartesian plane. So I have the number 2, 5. So x is 2, y is 5. This is where A would be. Agreed? B, x is -3 and B is 1. C is -3 and x is -3 and y is -5. So that's where C would be. D has a +7 for x and a -2 for y. So that's D. E is 0 for x and 3 for y. So that's E. And F is -5 for x and 0 for y. So that's F. Okay? A, B, C, D, E, F. And now it asks some questions about the quadrants. Which point above is located in quadrant 4? Well, quadrant 1, quadrant 2, quadrant 3, quadrant 4, that would be point D. Which point is located right on the x-axis? So here's the x-axis, right? This should be labeled x-axis. Actually, this is y. That would be point F. It's right here on the x-axis, okay? So pretty standard. This is pretty straightforward, especially if you've had some exposure to graphing before. But it's very important for being able to plot and not only points, but eventually equations and lines. Now we've got an in-class activity. Now normally I would give you a few minutes to do this in class and then we would check in with each other, but let's just see what happens here. Write the coordinates of each point shown on the grid below. So I have point A, so the coordinates are on the x-axis. I have a +6, and on the y-axis, it's a coordinate of 0, right? Point B, again, I have a coordinate of 6. And on the y, if I move over to the vertical axis, 1, 2, 3, it would be a coordinate of 3. Okay. For point C, I have an x coordinate of 2 and a y of 3. Notice they don't label every single number on the system, so you have to figure out if this is 5. They do give you some numbers, you can figure out the rest. This is 5, this has to be 1, right? So these are going up by 1s. And the reason they don't label everything is because it can read the graph if they labeled every single tick. Now point D is a -2, 1, 2, 3, 4, 5, 6, 7, 8, 8. Point E would be, let's see, -5, one more would be -6, and it has a y value of 0 again. It's right on the x-axis. Point F is a -4, 1, 2, 3, 4. H is a 0 coordinate for x and 1, 2, 3, 4 and a -4 for y. I is here, so 1, 2, 3, it has a coordinate of 3, 1, 2, 3, 4, and a -4. And finally, our last point, O, is the origin itself. It has coordinates of 0, 0. Okay. And then again, normally I would give you some time to work on this, but let's take a look. Plot the following points on the grid below, label each point. So A has a coordinate of 3, 5, 1, 2, 3, and then I move up vertically by 5. So this is point A. B has an x value of 0 and a y of 4. So x is 0, and I just move up 4 spaces for y. C is -3, -2. 1, 2, 3, -3, -2. That's C. D is -1, 6. So -1 for x and all the way up to 6. And that is point D. Point E is -2, 0. Point F is 3 comma negative 6. 1, 2, 3. 1, 2, 3, 4, 5, 6. That's F. G was 5 comma 0. And H is 0 comma negative 3. So X is 0 and Y, I have to move downwards to get the negative 3. So those are the points A, B, C, D, E, F, H. Okay. All right. Let's keep going on. In which quadrant or in which axis do each of the following points lie? Now, you have to either trust your memory or flip back and forth, or I could do a quick, or I could look at this grid down here, right? Or I could do a quick grid here, I guess. Maybe I'll do a real quick grid. So this is the x-axis, this is the y-axis, right? I know this is 0. So if x is positive and y is negative, so x would be positive, but y would be negative. So remember, that's down in quadrant 4. Okay, my quadrants are 1, 2, 3, and 4. If they're both negative, well, the negative signs of both are here, so it's quadrant 3. Okay. Both positive, that's easy. They're both positive in quadrant 1, and that makes sense. That's where everything starts. If x is negative and y is positive, that would be quadrant 2. Both negative, we know that's quadrant 3. Both positive, that's quadrant 1. X negative, so on this side, but y positive, so that's quadrant 2. This is interesting. X is 0, y is 4. So that's right on the y-axis. Okay. This is on the y-axis. Okay. It doesn't belong to a quadrant. It doesn't belong to any quadrant. Both negative, that's down here, quadrant 3, and x positive, so on this side, but y negative, dropping down, so it's quadrant 4. Okay, so if you think about it here, in quadrant 1, both coordinates are positive, right? Positive, positive. In quadrant 2, x is negative, y is positive. In quadrant 3, they're both negative. And in quadrant 4, x is positive and y is negative, right? That's another way you can think about it. Now you're gonna have to start getting used to seeing data not given to you as coordinate points, but given in tables. So when you're given data in a table, the x is the first column or the first row. X is always the first piece of info given, y the second. Just like in your coordinate points, right? In your coordinate points here, x is first, y is second. In table form, x is first, y is second. Again, just remember, follows order the alphabet. Plot the following on the grid provided. Now, I guess probably we should have labeled these, right? So let's label these A, B, C, D, E, F, G, and H. Okay, so A, x is 0, y is 9. Right, so it's the same thing. You're just reading. It's just like if this was the coordinate point, right? This is the exact same as this, right? 2, 7, etc. Okay, so x is 2, y is 7. I have to climb up to 7. That's B. X is negative 4 and y is positive 5, so that's C. X is positive 6, y is positive 3, so that's here. That's D. E, x is positive 8 and y is negative 1, that's E. F, X is 0 and Y is -5. That's F. G, I have a -5 and a -7. And H, I have a +6 and Y is 0, so it doesn't move anywhere. It just stays here. Okay. So that was either a refresher of the coordinate system or an introduction. And if it was an introduction, brand new, I hope it was pretty straightforward, right? That was lesson 1, the Cartesian plane. I think we'll move on to lesson 2. Lesson 2, describing data and displaying data and describing trends. So once we plot our points on the grid, now we did a lot of plotting actually. We plotted all these points, and we plotted here as well, right? These points were plotted first, and for patterns. And most of the data that we'll encounter in this class from here on in will display some kind of a pattern, because that's the reason we're studying it. It's going to show us something. If I look at this data here, I can see a definite pattern, right? And if you think about it, it kind of goes like it's following a path, a fairly straight path. They're not all lying on the same line, but they would be lying, if I drew a line of best fit, a line through this display of dots, and tried to link lots of the dots, then the line of best fit would be like it. I could definitely draw a line through this data, right? So these patterns can be described in different ways. In this unit, we'll focus on linear patterns, and you can see that word line is in linear. Our data resembles the shape of a line, right? So even though this isn't a perfect line, the data is traveling upwards. This data is traveling downwards in a straight line, I think. This data is traveling straight across in a line, in a linear fashion. This data is not traveling in any discernible pattern at all, this data. So it's just random. That's very similar to the data we saw on the points that we had just plotted. So let's take a closer look at how the data could land. These points are arranged in the shape of a line pointing upwards. Now, when I say upwards, we read our data in math. We read graphs in math just like we read our books in Canada. We read left to right. So that's how that's how I read this page. That's how I read the graph. So I'm reading this graph left to right, and left to right, the data is trending upwards. Okay. We say that this graph shows an upward trend. Okay. So what we're saying is, if you think about it, as we move across the page, you can see that we're moving towards greater and greater values, like we're moving to the positive side of the x-axis, right? This is the positive side, this is the negative side. This is the positive side of y, this is the negative end of y. So as we're getting larger and larger in x values, as we're moving across the page, we're also getting larger and larger in y. Generally, as the x value increases, the y value increases. We say there's a positive correlation, okay? So if x and y both increase, we say it's a positive correlation. Now, you can probably think what's coming up next for this graph. The graph shows a downward trend. So this is, as we read left to right, the graph is showing downward trend. As the x value increases, right? So this is the x-axis, even though it's labeled something different, this is the x-axis and it's getting positive. Okay, getting larger. This is 0, right? So we start at 0 and I'm getting larger. As the x values increase, right? So x is standing for the number of absences. As we move, my first data point has 0 absences. My second data point has 2 absences. And I move the highest number of absences, the highest x value is 12. What happens to the y values as the x values increases? The y values are dropping. So as the number of absences increases, the score decreases. We say there's a negative correlation, okay? So when the trend is downward, it's negative. And in this story, it makes sense in this context because as the number of absences, probably for students, if they increase, their mark is going to go down, okay? So if a line trends upwards, we say positive correlation. If the line trends downwards, negative correlation. Okay? If there's no change in y value, as the x values increase, so as we get larger and larger along the x-axis, there's no change. We just call this constant. Okay? There's no change at all in y. It doesn't matter what x is, just no change in y. And then this last one is random. It looks random. It looks like someone just took a bunch of dots and threw them on the paper, right? There does not appear to be any correlation. And we say no correlation. There's no correlation at all. So we have positive correlation trending up, negative correlation trending down, constant correlation, and no correlation. Okay. And what I think I'm going to do now is I'm going to graph this last graph, and then I think I might end it for the day and just give you time to, I hope I hear from a few more of you today. I'm going to do page 6, and then I'm going to stop for today. Okay, plot the graph of the data provided in the table. The table provides data regarding the number of absences per student and the student's final mark. Be sure to include your axes, labels, and a scale. Okay, so I strongly suggest you do this in using pencil, because it is very often you have to slightly adjust things. So if I look, my x-axis, this is going to be my x-axis. Okay, so what's that? And this is my y-axis. Okay, but these are the labels I have to use. I have to use the labels they give me in the story. So the number of absences is going from, let's see, this is my smallest number, right? So this is the minimum value. My largest one is my maximum value. So I have to pay attention to how low and how small and how big I have to go. And for the y-axis, let's see, the y-axis is minimum and then maximum. Okay, so the table provides data regarding the number of absences. Be sure to include your labels, axes, and a scale. Okay, so if I use the whole thing, right? Now, I don't need any negative numbers in this case, right? If you think about it, I'm never going to have a negative number of absences. The smallest number of absences could be 0. I'm never going to have a negative mark. So I think I'm going to use my whole grid like this. Okay. I'm just going to put arrows. Because I guess we could, I don't know, sometimes teachers give more than 100% if they have bonuses. I'm not sure. And I have to put my labels on. So this is the number of absences. And this is the student mark. Now, let's see, I have to have a low mark of 0 and a low number of absences of 0 and a high of 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I think I'll just go up by ones then. So 1, 2, 4, 6. So you don't have to label every tick. You just have to label some of them. And notice, if my scale is 1, right? If I'm going to go up by ones, then I have to be consistent. If I've chosen to count by 2s, then every 2 spaces I count by 2s. Okay, let's try the next one. So I have to go up to 97. If I just want to keep this at 0, which is 30, 40, 50, 60, 70, 80, 90, 100. Maybe I'll just do that, right? I don't think I can go up by 5s. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80. No, it'd be nice if I could go up by 5s, but I can't. So I'm just going to go up by 10s. 10, 20, 30, 40, 50, 60, 70, 80, 90, and 100. Okay, I'm going to switch to pencil now just in case I have to do some erasing. If I had a slightly taller graph, I could have gone by 5s, which would have made graphing easier. Okay, so let's see. When there are 8 absences, the student mark was 65. So for 8 absences, I find out where 65 is. So it would be right here. Plot a point. Now this time I'm not labeling them A, B, C's, and D's. They're identified by their number of absences because there's no student with, students don't share the same absences. There's only 1, 2, 3, 4, 5, 6 students. And I think I can keep them separate by their number of absences. The student with 3 absences had a mark of 90. So 3 is here. And they had a mark of 90. The student with 5 absences only had a mark of 85, which is still pretty good, right? So here's 85. See, 85 is halfway between 80 and 90. The student with 4 absences had a mark of 62. Okay, well, here's 65. So 62 is a little less than 65. The student with 0 absences had a mark of 87. So that's somewhere between 80 and 90, closer to 90. And the student with 2 absences had the high mark of 97. So it's between 90 and 100, but closer to 100. Okay. So let's see if we did this correctly. We can answer all these questions. What is the minimum X value? Well, that was 0. And the maximum X value was 8. And the scale is just, we used a scale of 1. It's the distance between the first 2 ticks, right? Like from here to here is 1. What is the minimum Y value? Well, we had recorded that as 62 and the maximum is 97. And we used a scale of 10. We used a scale of 10. Meaning we started counting by tens. Okay. Notice that in many cases, negative numbers are not needed. In these cases, we just need quadrant 1, which is what we did. We just used quadrant 1. Examine the graph of the data that you plotted. Explain what the data is telling us specifically about the correlation between the number of absences and the student mark. Well, let's see if we could figure out a correlation. This is kind of an oddball one, right? This 4 absences is really low compared to the others, but I think I see a trend, right? These 2 are a little off, but to me, 4 out of the 5 points make a really strong statement that it's a negative correlation, right? There is a negative correlation. So as the number of absences increases, the mark decreases. And that makes sense, right? If we look at the data again, as we move higher and higher along the x-axis, as we get higher and higher on the x, which in this case is the number of absences, as we get higher and higher on the x-axis, we're starting to move down on the y-axis, which is the mark. Okay? So I think I'll leave it at there. No one joined me on the Google Meet, unfortunately, but I think I'll post a little more info about that later today. Maybe I'm going to be opening up a Google Meet for resource every day at 10 o'clock that you can ask me questions about your math at 10 o'clock. And I'm going to leave you to do, instead of an assignment, I'm going to get you to work on example. Try and do as many examples as you can before tomorrow. Right? Try example 2, 3, and 4. Those are the ones I'm going to do tomorrow. So hopefully you can get working on that. And I'll post the homework on the blog. Also, if you have any questions, you can email me. I only received 1 test in from this class. So the tests I posted 2 weeks ago, I guess, or a week and a half ago on the last day of school. If you need any more info about that, you can just let me know. And I will talk to you tomorrow.